Okay, a standard deck of cards contains 52 cards. One card is randomly selected from the deck. Compute the probability of randomly selecting a 2 or 3 from the deck of cards. A has the idea of probability of 2 or 3, which is the same thing as the probability of 2 plus the probability of 3 minus the probability of a 2 and 3. This is just the general addition rule for probabilities. So then we need to know the probability of a 2. Probability of a 2. There are a total of 4 2s in 52 cards. And if you don't know anything about cards, it's a great time to go learn about cards. So go buy a pack of cards from Walmart before the end of today. You'll be good to go. Probability of a 3. Same exact probability. There's only 4 3s in a deck of cards. So 4 out of 52. And then minus the intersections. So this is where it's easy. There's nothing in a deck of cards that's a 2 and a 3. So there's no intersections whatsoever. So it's minus 0. So then we put those numbers together. 4 out of 52 plus 4 out of 52 gives you 8 out of 52. Which will be reduced down to 2/13. So there's your answer for A, 2/13. B. Compute the probability of randomly selecting a 2 or a 3 or a 4 from the deck of cards. B builds off of the idea of A. So we're looking for the probability of a 2 or a 3 or a 4. Since we know in a deck of cards there's no 2 3, there's no 3 4, there's no 2 4, we don't need to have those anymore, so we can just ixnay those. So this is just simply the probability of a 2 plus the probability of a 3 plus the probability of a 4. Each one of these has the probability of 4 out of 52. So 4 out of 52 plus 4 out of 52 plus 4 out of 52. You add those numbers together, that gives you 12 out of 52, which reduces down to 3/13. There's your answer for B, 3/13. C. Compute the probability of randomly selecting a 2 or club from the deck of cards. So this we are looking for the probability of a 2 or a club, which is the same thing as the probability of a 2 plus the probability of a club minus the probability of a 2 and a club. So now probability of a 2, 4 out of 52. Discussed that already. Probability of a club. Now you gotta think. Each suit has how many cards? There's a total of 13 cards in each suit. So then there's 13 out of 52 clubs. And then here's the part that most people will forget. There is an intersection between a 2 and a club. There is a 2 of clubs. So we have to subtract that one intersection. Put those numbers together. 4, 13 minus 1. That gives you 16 out of 52, which reduces down to 4 out of 13. So 4/13. Boom. That's C. Now, if you notice, I skipped example 3. Example 3 tends to follow 1 and 2, so I leave it for you to do in order for me to save some time.